Well, welcome. Thanks for coming out. Appreciate everyone who showed up at the start. If you don't want to stay, that's fine. I won't trip you at the door or anything. Too hard anyhow. So thanks Star Trek for having me, first of all. I spoke here a long time ago, about 2018, I think, and it didn't go so well. So I'm so glad they had me back for round 2. I've been speaking a lot lately in the last couple years. Yeah, I think we're going to have a good time today. I'm going to move pretty quick. This is a 60-minute session. I think we're going to get through this before 60 minutes probably, so there'll be plenty of time for questions. We'll go from there, but I think we'll be done before 60 minutes. I like to keep folks updated in our progress through the presentation, just so we know how far we are making it through. So thank you also, Star Trek, for not putting me in a pre-lunch spot. For some reason, conferences like to put me at 11 a.m. or something. And everyone's hungry, and you can hear it in the room. Instead I get the 2:15 slot where everyone's just about to fall asleep, so that's cool too. I'm not upset. Anyway, so this is a promise that you'll understand asynchronous programming with JavaScript. And promise is kind of a strongly worded. Obviously, you get the joke, you get the pun, right? But it's a strongly worded title, so I'm just going to go ahead and you'll probably understand it. I hope you learned a little something today. We'll talk about that in a minute. A little bit about me. My name's Bruno. I am, see my slide's so tiny on here. I gotta blow this up a little bit. And I can't do this because it's giant. I have a website. I'm on LinkedIn nowadays. I'm on Twitter, X, whatever, but I don't really post nowadays. Flew up from Atlanta, Georgia, so awesome. Question mark is because we're not staying there. We're on our way out and probably coming back to Ohio, where I am from, Bowling Green originally. So we'll see what happens. I talk, like I said, I talk quite a bit. I hike in North Georgia. North Georgia is beautiful for hiking and wineries and all that stuff. And I'm also a student pilot, which you'll know because like every pilot, they'll tell you. I just have to. I'm not associated with NetJets or anything, but they do have that little sim out there, which was fun. I'm a 25-hour student pilot, and it's more to learn. Just a sidebar, if you ever feel like every flight school in the country has an introductory flight they'll do for $100, $150. If you're even remotely interested in doing it or you just want to do something fun for your birthday, it's a good $150 to spend to go up and spend 30 minutes buzzing around your local airport. So a lot of fun there. This talk came about because I had a coworker one day, kind of in a condescending way, said to me, he goes, I'm one off here. He goes, you're teaching promises? Why? Everyone already knows promises. It's part of JavaScript. It's part of the spec. It's been around for a while. And I've given this talk 5 times, and it's always filled up the room. I think there's a lot of interest. There's a lot of what ifs. There's a lot of there's a lot to know about promises. They get pretty deep. I was always puzzled by that approach. I'm like, there's always something to learn. And more importantly, I'm not teaching. I've used promises before, poorly. I learned from my mistakes. I got better at them, and then I put this presentation together. I'm here to share my experience. I'm not an expert in the subject necessarily, so everything you're going to see today is my personal experience. It's the way I learned everything I know about promises, so I hope you take something away from my approach here. This is unfair to the people in the other room, but who is working with promises today? Who writes them? Who uses them? It's part of your daily. Got to block this light out. This one over here. Okay, I see a few hands. So not as many as I think. The last time I gave this talk at Momentum Dev in Cincinnati, the entire room went up. There was a room full of experienced devs, and it was actually a really exciting talk because there's a lot of back and forth banter. So feel free to holler at me. By the way, if you have questions, you can ask them as we go, but you're going to have to shout them at me. I'm not going to see you with all the lights in my eyes, so feel free to stop and ask questions. Anyway, so that's encouraging. Again, I go to conferences because I'm curious about new topics that I wouldn't normally explore, or I go into topics like this one, or JavaScript talks in general, because I want to reinforce the things I already know. Sometimes it's nice to just be told and see that, yes, I'm doing things right. I agree with what's going on. It's a good thing. So this presentation will cover the basics of promises. There's going to be a lot of code on slides, so I'm going to go through them pretty quick. This is not I don't want this to be dry and obviously we don't want it to be boring, but I don't want to spend time dwelling on a lot of code. I'm going to move to snippets on slides very quickly, explain them, move on, and we're going to just kind of rush through this. So that's what we're going to be doing today. You've probably written or consumed or seen JavaScript code that looks like this, right? And see, this is going to be easier if I flip this over. Get data from server. Obviously, it's an async call of some kind. We have these then statements that we worry about. We have these .catch statements. And you've seen code like this where we have this async thing and we have these awaits. And listen, I've been guilty of writing code because the document told me to. And I didn't really know what it was doing. I did this for about a year or so where I was like, okay, I was using asynchronous programming, but it didn't interest me. I did what I needed to do. And that was bad. Don't do that. So I'm here to hopefully clear some of that up. The goal is by the end of this talk, you'll have at least a good, solid understanding of why we use these tools, why we use this syntax, and what's going on under the hood. Oh, see, I spoiled my next slide already. Look at that. So, part one, plain and simple. What is asynchronous programming? So I went off and I asked Google, what does asynchronous mean? This is a few years ago, and it was not useful, not helpful. So I did the stupid thing, and I asked Siri next. I said, "Hey Siri, what does asynchronous mean?" And she's like, "Okay, cool." Not helpful. Not helpful. I don't remember where I got this definition, but it's the one that made sense, right? Events not coordinated. Oh God, I'm going to spill the water. Events not coordinated in time. Keep that in mind because that's going to come back a couple times. I'm going to reference that definition. Something that's asynchronous is events not coordinated in time. Simple example. Let's make steak and potatoes real quick. It's not going to look like that. How would you cook this? If you're cooking synchronously, you're going to put a steak on the grill, you're going to season it, you're going to cut it, you're going to put it on the plate. Then you go to your potatoes, and you're going to peel those, you're going to boil them, you're going to season them, and then you're going to bring them up and put them next to your... What happens if you do that? You get a cold steak. And probably cold potatoes too, depending on the order, right? Not great. You don't cook like that. You cook like this. You peel the potatoes, you get them boiling, you season the steak, you put it on the grill, you cut your meat, you season your potatoes, and you put everything together on the plate more or less at the same time or close to it. We're going to talk about the difference between asynchronous programming and parallel programming and parallelism in general in a little bit. So we've seen synchronous code. How do computers execute code? Bar none. At the most basic level, no matter what we're doing, computers execute code one line at a time, right? Simple, top to bottom, one line after the other. But what happens when we do this? What happens if we execute a line and, okay, get content from server? We don't know what that's doing, but it's probably going out and doing a network call. We're stuck. We don't know how long this is going to take. We don't know when this is going to finish, but executing line by line like this, we're going to have to stop and wait. And wait. And eventually we finish up. Again, it could be milliseconds, it could be seconds, it could be minutes, we don't know. What if we can execute code in a way where each of these different methods just goes off and does their own thing, and we don't have to worry about when they're done. We don't care when they're done. We just want to handle some result when they're done. So again, we're executing these functions. We call function A and function B and function C. In this case, they're called load form data, get images, whatever. We're going to execute those functions, but they're going to go off and do their own thing on their own time and their own schedule. We'll deal with them later. All right? That would be ideal. An ideal way to get out of this, some of these blocking situations that we're going to talk about. Why is asynchronous hard? This is just me thinking out loud for a little bit, so I'm open to some ideas as well, so if you want to shout any out here. But fundamentally, writing code is just, it's doing things one after another. You write a line of code, it executes. You write the next line, it executes. The next. It's very simple. It's one task at a time, essentially. We roll those up into functions, and we expect functions to execute in a certain order that we prescribe, and all kinds of other things. But with asynchronous tasks, things start going different places, and we have to keep track of that as humans. It can be very confusing. That's probably, for me personally, this is the most fundamental piece that doesn't work. It's like, okay, I can write code that, executes this line, but oh wait, then this next function is going to go off and do something over here, but the program still continues. You lose track of what's going on. So when you're reading and trying to interpret a program yourself, it can be very difficult to follow that logic. The computer doesn't care. It knows what to do. I've also made this mistake, and feel free to don't raise your hand. I can't see you. But if you want to, I've done misunderstood control flow. I've actually written code where I go off and I get some data from some server, and the documentation, or I know I'm supposed to write a .then and a .cache to handle some things. And then later on in my program, I go, okay, well, I want this data, right? This data that came back from this function, this get data from server. I want to use it down here, and I'm like, that doesn't work. That's not how. This is a syntax thing, of course, too. But this is not how it works, right? This is not how asynchronous programming is handled in JavaScript. So I got some data from server, but I can't use it farther down in my application. So real quick, let's talk about asynchronous versus parallel programming, because there's definitely a difference. So I live in Atlanta, Georgia for the time being. It's been a great 7 years. I do like it down there. People are pretty friendly until they're driving. You guys have no idea how good you have it here. It's amazing. Flew in last night, drove across the city in 20 minutes. Good. Weather's pretty good down there. The food is really amazing. I do love food in Atlanta. I've fallen in love with Korean food especially. It's so good. There's one thing Atlanta's kind of infamous for. Obviously, I alluded to it. We have so many cars. So that's my example. I keep adding arrows to this every time I give this talk, so eventually this is going to be like it's going to crash PowerPoint, and it's going to be a good day. So let's pretend that we're going to do a commute. Oh, that does not come through too well in this. Anyway, Atlanta over here. I actually live way up here in the Lawrenceville area in the top right corner of that slide there. So let's pretend we're doing a commute downtown, which I don't do because I'm remote, but whatever. Here's an example. Tell me if this resonates with you. Synchronous programming is essentially putting a bunch of cars on a one-lane road. One car goes down the road, the next car goes down the road, and it's a single-lane road or a two-lane road, right? You can't pass. That's synchronous programming, one thing after the other, from home to work. Parallelism, and I'm not going to go deep into this topic, but the general idea is that you want to do a lot of things all at the same time, and this is where our infamous highways come in. I-75, I-85 downtown, the downtown connector, actually has 2 more lanes than this picture. But the idea is you put a lot of cars on the road at once, and they're all going to more or less the same place next to one another, ideally, when they're not stopped. So asynchronous, then, is this idea that each car takes its own path to downtown. Single lane road, 1 car per path. They're going to get there at different times. They're going to get there their own way. You want to handle the result of this, which is them arriving downtown or at their jobs, right? So I don't know if that example's like super useful, but that's the one I came up with while I sat in traffic one day. Let me know. So asynchronous programming, to kind of just summarize it then, is really, it's code that executes in a non-coordinated way. And we're going to revisit this when we talk about promises specifically, and I'll highlight some good examples near the end here. Asynchronous programming should always handle the result of what's being executed asynchronously. If you send something off to execute asynchronously, you probably want to handle some result or know when something's completed, right? So that's a requirement, and a feature that promises bring to the table. And then asynchronous programming, code should be non-blocking. We'll talk about stuff like UIs and network access and things like that. But if you've been writing JavaScript for more than 25 years now, I think since version 1, we've had functions like this: set timeout and set interval, right? These are built into the language, version 1, version 2, I'm not sure. It's been around for a while. These are actually asynchronous functions baked into the language. They've always worked. You know how these things work, right? Execute some function after a given number of some length of time. And so we've had some version of asynchronous programming sort of in the language. We've also done things that kind of are asynchronous in a way. For example, here's a method, get data, we pass a URL, we pass a callback. So if you've used callbacks before, probably everybody has. It's kind of like asynchronous programming in the sense that we're going to execute something after something else. We're going to handle the result of something. So in this function, let's load some data from some server, and when that's done, we're going to execute our callback. So it's sort of asynchronous in a way. But what we really need is a better API to handle the nitty-gritty of asynchronous programming. and that's promises. If you ever present, like, don't forget the water. Big tip. The only thing I'll say, and maybe it's just because I fell behind for a while, because I'm more of a .NET dev, so the JavaScript side has fallen by the wayside for a few years there. I missed a lot of the really good ES6 stuff that came out around 2015 or so, something like that. ES5 was 2009, ES6 was 2015. So if for some reason you're not using arrow function expressions or don't know what they are, it's a good prereq for working with promises, because it's a syntax thing. It's simpler. It makes code cleaner. So just keep that in mind. I won't dwell on that slide too long there. But why were promises added to JavaScript? A bunch of reasons, but one of them is this. A bunch of different names for this. This is, I think, callback hell, pyramid of doom, or something like that, right? When you start stacking a callback and nesting callbacks and callbacks and callbacks and callbacks, this gets pretty ugly. And we're going to see another example of this when we start talking about chaining dennables as well. But it's not great to look at. So we really need a good API to handle promises in a clean, simple way. So what is a promise, plain and simple? If nothing else, these next couple of slides are kind of the core of the talk, at which point you're more than welcome to leave, but don't do that. A promise really just is, it's a proxy for a future value. We'll talk about that in a little bit, but really you can boil it down to write some code that does something, and when it's done, we'll either resolve that, and return a success value, or we'll fail and we'll return some value. And the key here is that code executes asynchronously. And the interpreter, the JavaScript engine, just handles that. We'll talk about that as well. The other piece here is that promises are guaranteed. And they're guaranteed to return that value. Like if you dispatch a promise, it will succeed or it will fail. But it won't do that if you blow up the program another way, you throw an exception, whatever, that's obviously going to cause a different issue. But promises are guaranteed to return that success or fail value, at least one time. We'll talk about that a little bit as well. Promise lifecycle. This is a whole nother talk, honestly, because there's a lot of pieces to it. It really boils down to a couple of different states. So promises always start in the pending state. So when you new up a promise and you dispatch it, it's just going to show up as pending, and eventually it will fulfill or succeed, and then we'll resolve that. We'll talk about that a little bit. Or it's going to reject, and we're going to handle some kind of error condition. So you'll see I introduced the .then and the .catch. We'll talk about that here very shortly. And we call this resolving and rejecting. A promise that is fulfilled or rejected is just known as settled. So this is just kind of vocab terminology stuff. I screw this up all the time when I'm talking to teams. By the way, I didn't do this in my intro, but I actually don't write code anymore. I'm a sales engineer. It's a great job, but I do this on the side. I write code on the side now to stay sharp and have fun. But when I do talk to folks, I do screw this terminology up all the time. But fulfilled, resolved, rejected, failed. I think folks will know what you're talking about. Promises. What do you need to include? What do you need to use in your app to use promises? And you don't need to use anything nowadays. It's been around since ES6. There's a bunch of changes to it that have happened over the years, but it's a global object. It's just that, among all the other stuff that you use at the global level, there's promises. So it's available anywhere you need them. And if you are going to look at a promise in the browser, and I'll show you some code near the end here that will highlight this. You can look at these things, right? You can look at things like lifecycle. So you can see a pending promise has a promise state, and I'm just curious how this looks from all the way back here. Oh, it's beautiful up there. Promise state, promise result has values. A fulfilled promise has a state fulfilled, and it has a result, some value. It can be whatever you need it to be, a string, a number, whatever. And then a rejected promise has a state and a result. And these values come right from the browser, right? If I open up Chrome or Edge or whatever, I can inspect those exact values, and there they are. So I pulled those straight from that example there. So there's a little bit about lifecycle, kind of high-level stuff. I'm going to pause just for a second. Is there any comments or questions so far, just at that level? Because I've gotten some before. I've been told I go through that pretty quick, but I'll just pause for a shout out because I can't see anybody. But.
What might proc a promise failure?
Okay, so like when a rejected promise, in other words? Okay. I'm going to put you on pause, so we're going to get to that in a second. Let's talk about writing promises then and handling promises. The promise signature is it looks more complicated than it is. You new up a promise, and the promise itself takes a function, which the function takes two callbacks, resolve and reject. Those are functions, function callbacks. Keep that in mind. We typically write it like this, just because, like I said, the arrow function expression is a little more concise and cleaner to write, and this is kind of my preference nowadays. So this next slide will answer your question. I just realized I'm blocking my, anyway. So let's talk about what's in a promise, because we're going to talk about the actual body of a promise. So I'm guilty of, first of all, I don't write promises very often, but I certainly consume things that return promises, and probably everybody here does too. You definitely work with a library or a JavaScript method. If you ever use fetch, for example, that's all asynchronous. So you've written the consuming code of a promise, the .thens, the .catches, right? The asyncs, the awaits. But the body of a promise is a bit different. So if you haven't seen it before for any reason, this is it. And what's in a promise? Well, there's a promise object that we newed up, right? We have our success function, we have our failure function, or resolve or reject is the proper terminology. We have our async code. So in the body of a promise, just write the code, do the things you need to do asynchronously. Everything in the body here is going to be executed asynchronously. It can be one line like this, just go off and do lots of work, make a network call, do some UI, whatever, okay? Database stuff, it doesn't matter. Everything in this body is going to be done asynchronously. When that code is done, we'll talk about the rest of this in an upcoming slide, but when that's done, that's where we're going to get to the resolve and reject. So before we do that, let's talk about the other side of things then, which is our thenables. And as I just said, how do you handle the result of a promise? When it's done, when that code goes off, does its thing, and it's complete, how do you handle that result? Well, that's what thenables are for. You can use off of your promise, .then, and you pass it in a couple of functions, a resolve function and a reject function. You notice I'm not giving you concrete examples here. These are pretty abstract. The code I'll give you at the end of this talk on my GitHub goes into a little more depth here. But these two examples are equivalent, but I don't see the top one used a whole lot. The .then method can handle both a resolve and a reject function, but for the sake of clarity, I do see it on the written as the bottom example a lot more. You use an explicit .then and an explicit .catch. .then simply when your promise resolves and succeeds, the .then is called, and when there's an exception or it fails for whatever, not an exception, when it fails or gets rejected, the .catch is called. So going back to that example we just saw, here's our promise, here's our resolve and our reject callbacks that we're going to pass in as part of our thenables. You'll see that in a second. Go off and do lots of work. When that work is complete, and to your point, how do we know if a promise succeeds or fails, resolves or rejects? That's entirely up to us as the developer. So in the body of a promise, we go off and do a bunch of work asynchronously, and then we just check for some success condition. In this case, it's obviously like a Boolean value or a truthy value. It could be a check for a 200 HTTP status. Whatever you determine to be success or failure point, that's logic for you to figure out. But the point is, when you're ready to resolve that promise, you call that resolve callback method that you passed in, or that comes in. And this actually maps, this is a little bit of magic, right? This maps to the .thenable, or the .then thenable. So when resolve is called, we call that .then, and if we reject the promise in our logic, we call the .catch. And we'll be talking about the async and await side of this a little bit later, but keep this example in mind. And you can resolve a promise at any point, right? You can just new up a promise and resolve right away, and boom, you're done. So do work .then and output it, and we're going to get that that complete. We're going to get that value. You can do the same thing. You can reject a promise right away if you so wanted to. It doesn't matter. You don't have to necessarily do a lot of work here, but you can reject and resolve a promise willy-nilly. And it's going to execute our catch in this case. And you can go wild or don't. Probably don't, right? So you can go and do as much work in a promise as you want, call all kinds of functionality and logic, and then resolve and handle that. Don't do that. Think single responsibilities here. Promises really should just go off like any other method and do as little work as possible. Do one thing, do it well, get in, get out. When should you use promises? This is not a question about promises. This is actually a question about asynchronous programming at a higher level. So this really does go beyond JavaScript, but yes, really boils down to promises. When should you use asynchronous programming? When you want a responsive UI. So if you're doing anything that's going to block the UI potentially, this is a good case for it. Now that said, you can still block the UI because of promises. Like if you try to calculate prime numbers in a promise, you're still going to hang up the browser. We'll talk about that in a second. Anytime you do a network request, it's a promise. It's going to be asynchronous code, right? Anytime you're doing like task or event-based work, it's asynchronous. It's a promise. And if you're using any modern JavaScript API, it's probably going to be asynchronous code. Almost every modern JavaScript API in the last probably 5 or 6 years is largely asynchronous operations. So that's a lot of the reasons you'll be using asynchronous programming. I just added this slide to this version of the talk because folks asked about this, and this gets into some nitty gritty. I don't want to go a whole lot into, but promises occur inside the JavaScript browser event loop. So the JavaScript engines are big beast in themselves, but they really just boil down to an event loop structure. So in other words, for JavaScript to execute, the interpreter, in this case in the browser, just waits until there's work to do, right? And then it goes off and it executes JavaScript in what's called a macro task. Macro task is really just any kind of script execution or user input. Major things you do in a browser are handled as a macro task. Beyond that is a micro task, and a micro task is really just there to handle the promise stuff. So in other words, the thenables, the result of promises, get executed as a micro task. The point I want to make here is that these are both queues, so work, things are coming off a queue to get work done. Ultimately, the browser re-renders, and then we start the loop all over again. The reason I'm bringing this up is because promises in JavaScript in the browser, it's still single-threaded. Like we're not talking about parallel programming. We're not talking about multi-threaded programming here. Not going to talk about all the other workers that you can execute. It's separate from that, right? Promises work in JavaScript engines, especially browsers, as part of the browser event loop. It's still single-threaded. It's just that we can get so much work done so fast on modern computers. It looks like it's a parallel type thing, or we can just do a ton of work. Like I said, if you calculate prime numbers in a promise, you're still going to hang up that macro task. That's new. You can just tell me to leave. Like, you don't have to. That's never happened before. I mean, when I saw the first Spider-Man in 2002, this happened, but I got a free movie ticket out of it, and that was about it. Yeah, I can do this without the slides, but it gets awkward when I start spelling things out manually. We're moving at a good clip, too. We're actually down to the last about 15 slides, and then we're going to go some code examples and be done. So, you guys just wanted me to do the full 60 minutes, I see. It's okay.
Apparently we have a full house in the other theater, too.
Oh, no, really?
Yeah.
Oh, well, thanks, guys, for showing up to that one, too. Where's the camera? Nothing a little reboot won't fix. My mom hates me for doing that. Did you turn it off and turn it back on? Every time. Did the event loop stuff make sense? Because that's a new slide for me. I haven't really got a good talk track on that. Like, the point is, JavaScript promises are not multi-threaded by any means. It's still part of the event loop. It has to go through, and you can still blow up a browser by giving it too much work. Like, you can't, if you need to do a lot of work in the background, it's not asynchronous programming necessarily, it's service workers or web workers. Any comments? Is there anything that's been demystified or just kind of confirmed, or is this making sense so far?
Yeah, it's great so far. Like my major issue is always figuring out how those responses come back and knowing
Gotcha. For the longest time for me, it was the body of a promise. What goes on inside of a promise? How do you write how do you new up a promise and actually write asynchronous code? I never did it, didn't care to. And then once I figured it out, and I'm like, oh, that's the magic of how things are happening. So we got a few more pieces to go through here to finish out, but. I bet they edit this out of the YouTube video. They better not. Well, while we wait, comments, questions, I'm always open.
I've got a question from the abyss back here.
Yeah, I just hear you.
Nice. So, in my opinion, one of the reasons why async is confusing, at least to me,
Yeah.
is because when I hear the word sync, I think like at the same time. So then I think async,
Oh, yeah.
not at the same time. As I understand, as far as I understand async, it means that things are happening congruently at the same time. So are there like any tips? First off, maybe I just confused the hell out of you. But
Happens all the time.
kind of keep that in my head. Am I thinking right?
Anyone else want to do this one? Because I got nothing. No, I see what you mean. Like I can see they got the words backwards. I think is what it boils down to, right? Like I heard you. I definitely understood what you mean. But yeah, it's just the definitions are just flipped. Like synchronous programming is one thing after another, right? Asynchronous gives us the option to kind of do things out of sync. Oh, I hate that definition. God. Literally never coming back here again.
I think one of the things that helped me understand was there are multi-threaded things that browsers do,
Yes.
like file system things,
Yep.
web
Web workers,
workers,
right? Service workers.
HTTP requests. So, like browser code versus user code, blocking versus non-blocking.
Yeah. Yeah, there are things that are truly, it's asynchronous, but it's done. It's almost as parallel. Yeah, there's true multi-threading things that the browsers do. To your point, promises are not one of them. What time do people get into work in the theater to start these things up? Like before a movie starts, they have to get here at like 4 a.m. or what? Sorry, go ahead. Are there other ways to do it? I really don't know. I mean, promises they're added specifically to be an API for asynchronous programming. Like my example, I had callbacks, function callbacks, where you pass in a function to another function as a parameter to execute some logic after something else happens. It's kind of like asynchronous programming to a degree, but it's not the same thing. It's not truly being done asynchronously. You can still block, like with a network request. Yeah, that one was. Sorry, if you speak up a notch, I can. Can I trust it though? Is it going to be okay? Like, I'm just going to go through my last 15 slides, like boom, boom, boom. Can I get back to that question? Okay, 'cause I want to revisit that at the end. Don't let me forget. Okay, no, we'll do it now. Everything's still single-threaded. Everything's still technically, what was the term you used? Serially, yeah. It's all still, it's single-threaded no matter what. It's just that the way tasks and code get stacked up in these queues for execution kind of determine when things happen. I believe, the body of a promise, the actual asynchronous code that gets executed, is a macro task. So it's part of the main JavaScript loop. It's just handled slightly different. So like if network request goes off to be made, but it's done in a promise, it's going to execute in a way that doesn't stop the rest of it. It's going to execute some portion of that task queued up for the next run through the loop, and then when it's done, when it finally gets to a resolve or a reject state, then it passes that off to the micro task queue where the rest of it, the result of that promise is handled. So there's just some smart logic in how the interpreters or JavaScript engines work that handles all that. But yes. Okay, let's do this before things really bomb out here. Part 3. So we're almost to the end, but there's still a lot to go through. I'm going to go quick. There's a lot of code on slides. And the result of this, though, I'll point you to a YouTube. Oh, geez. Point you to a GitHub repo that slows everything down that you can kind of play with a little bit. So promises were introduced in ES6 2015. So it's been a minute. Excuse me, please, lunch. Everything you've seen so far applies to that version. Everything you see up here, no, that's just lies. These things came after that. So ES, I think 2017, ES 2018, 2019, introduced some of these other things. These are composition functions. So check browser support. I think these are all pretty well supported nowadays. Then if you're in a server-side situation, I think these are all supported anyway by now. Those are, Node, and that's pretty good at supporting things very quickly, for me anyway, with stuff I do. But yeah, composition functions. So imagine in a situation where you dispatch promises more than one, right? Hey, I'm going to handle this promise, and it comes back, fine, easy. What if I dispatch 1, 2, 3, 4, 5, 6 things at a time, but they're related? Again, it's not parallel programming. Parallel programming is usually concerned with things like performance and keeping things in sync, right? Send off 5 things over here, and then we're going to sync those back up and make some sense of them. But composition functions allow us to work with multiple promises at a time and handle the result of multiple promises to some degree. So we'll talk about these real quick. The last piece, it looks like a throwaway, like async and await up here. It looks like a throwaway piece at the end. It's actually one of the more important things to go through. So we'll get there and then pause. So we'll talk about this quickly. Promise.finally. It does what you probably think it does. So I write .then, I have a .catch, so I handle the result, the resolution of a promise successfully, the rejection of a promise through .catch, and then finally just always runs. It always executes whatever's in it. So like a try-catch finally block in almost every other language ever. Same thing here. We can just execute something after every promise is executed, or every other branch of that promise might be executed. So promise.any is a composition function that returns the first resolved promise. So given 3 promises here, any will return the promise that was resolved first. So you see the times I put up here? I have my little arrow animation that's supposed to go along with it, but it doesn't work that well. The idea is that, of these three promises, 2 resolved and 1 resolved before the other. So this will spit out promise B, right? 500 milliseconds, it resolved first. Even though we see rejected, we don't care about rejected. .any only cares about resolved promises that succeeded. And we'll get that, and we can handle the result of that promise then. So that code's pretty straightforward, I think. Here's our 3 promises. We left out the details of what's going on there. We just pass it an array of those promises to our .any method, and then our .then method will simply be the result of whatever promise resolved first. So in this case, it's going to be promise B. Will succeed to that .then statement. All settled is very handy in the sense that it basically spits out the result of all of our promises. Doesn't matter if they succeeded or failed, resolved, rejected, right? Once a promise is settled, once all the promises are settled that get fed into that, we simply get the status of those promises. All right, one's rejected, one's fulfilled, and we get our values, our reasons in this case. Again, the code for that's pretty straightforward. It's a little small in there. It's looking good on there. It's so much easier up here. So, given this array of promises, just 2 in this case for demo purposes, we're just going to inspect the result of those promises. Again, this won't execute until they all come back. If one promise resolves in 5 seconds, the other takes 15 seconds. At 15 seconds, we're going to execute this this thenable here and get that result, and that's what we're going to get back. Race simply gives us the first promise that settles, whatever the result of that is. So in this case, we reject right away, and we resolve 2 promises in some other time. Race will simply give us back our rejected promise. So we can go handle the result of that. So what I don't do is, I'm not giving any specific real world examples of this, of when you might use these, but you can kind of get the idea is that if you need to dispatch a bunch of network calls, you only care about the first one that succeeds, or you want to handle the result of all 3 or 5 or whatever you dispatch, there's methods to do that here. So that code for promise.race looks a little bit like this, right? We have our 3 promises. We pass that array of promises into .race. And then depending on the outcome, we will handle the resolve promise that wins with the .then, or we'll handle the rejected promise with our .catch thenable. All right, so venable hell. It's a real thing. I guess that's the official term. If there's a more official term, I need to know about it because it feels weird. You've probably written or seen code like this. Get data from some server and then handle the response. If this response succeeds, let's go transform that data. And then when that's done, we're going to take the result of that. And if it's not null, we're going to set that data. When that's done, we're going to set some status. So whatever. You ever written this kind of nested code that just keeps going deeper and deeper, and you start, this is when you become a tab person, not a spaces person, for sure. Don't do that. Just set your tabs to be 4 spaces. Whatever. 2. I don't care. Not upset about that at all. Anyway, so the result here is that as a human, again, the computer can handle this. As a human who has to read this code and maintain it, this gets a little tricky after a while. This gets to be a little trouble. So I don't like it. That is where, and this isn't the only reason we have it, but it's a darn good one. That's where async and await come into play. So in the abstract, I think I actually wrote out and said, hey, async and await is a good way to handle and fix venable hell. That's probably it is one of the biggest reasons, but a lot of other good reasons to use this. So async and await fix that weird chaining issue. And let's take a look here real quick at what's going on. So we have this async keyword up on our function. We have this await keyword on some of our logic here. And what's happening here is we call process data, and the async keyword just tells the interpreter of the JavaScript engine, don't wait for me. At some point, this function is going to pause. It's going to go off and do something asynchronously. Just don't wait for me. Just keep going. Like, keep executing whatever's next. Whatever line of code is after process data, when I pause, catch up with that and keep going, in short. So inside process data, we're going to do almost the exact same logic. We're going to get some data and transform it, and yeah, we're going to get some data, transform it, and the await keyword simply says stop and wait here. Go let this promise resolve. My library.transform data returns a promise. It is a promise. It's asynchronous code. So the await keyword just says stop and wait. We'll hang out. Again, async function, so the program will continue around that. Same thing. We're going to await set data. It's going to hang out until it's done. It could be instant. It could be longer. Then we'll continue on. We'll set our status, okay, whatever. And I realized I screwed up my timing on that slide. But the point is, those 2 keywords are basically telling the interpreter when and where to pause and not to pause. This next slide really, hopefully, brings everything full circle there. So on the left is our promise chain that we saw earlier, and on the right is the async and await. These are functionally the same thing. Same code that does executes all the same logic. Which one would you rather read and maintain over the long term? You can say left or right. That's all I'm looking for. Oh, thank you. The last group, no, not the last group. The Kansas City developer folks said left, and I was like, what is wrong with you? Oh, it's going to be on YouTube, isn't it? No, that's okay. They still love me. I'm going to get uninvited. Cancel my flight. Async and await's a pretty deep topic. I kind of glossed over it. The idea is that you can write asynchronous code without venables. That's really what it really boils down to for the sake of this presentation. It lets you take the code on the left and write it in a way that looks much more, I guess, kind of procedural in a way, right? Like it's line 1, line 2, line 3. You can follow that as a human a lot better. The key thing to keep in mind, and there's my 45 minutes, so I'll wrap up here in a sec. It's much easier to read in the long term. I do encourage you. I'm not the authority on promises. There's a billion examples out in the web. My GitHub has a great example to start with for sure. That is, code right from these slides that you might recognize. Once you set a breakpoint in the browser and start playing with async and await, it really starts to make sense. Here's a real example from the code you'll have. Here's an async function, get trail data. This actually returns a promise. Async is actually telling the interpreter that this function will return a promise. So we're going to have to handle that later too. And inside here, everything we do can be done asynchronously. So get trail data, fetch some URL, and we call fetch, which is a native JavaScript function nowadays. We're going to await that. So when we get to this line, we're going to pause, we're going to stop execution, we're going to let that thing go off and do what it needs to. And when fetch is done, we assign the result. Now, some details I'm glossing over, and feel free to find me after this and I'll explain it in more detail. One detail I'm glossing over is that when fetch as a promise resolves or succeeds, automatically returns the value to the left side of the assignment operator. So I apologize for glossing over that a little bit earlier. I'm going to go back to this slide here real fast. So same thing, when we get data from server, when it resolves or succeeds, it just takes the result of that and assigns it to the variable here. If it was to reject at any point or fail, then it's actually going to hit that try-catch block, right? So same concepts. We still handle the resolution, or we still handle resolve, we still handle rejection or reject. The syntax is a little different. The concepts are the same, just a little bit different syntax there. We'll always do the assignment here when we resolve. We'll always hit that try-catch block when we fail or reject. So I'll catch up here real fast. So we call get trail data. We go off and it does a bunch of things. It returns a promise itself, so we handle it with a .thenable, and we do something with it, and we log it out to the console. So few key takeaways just to take home with you. Promises are just an API for writing asynchronous code. That's it. It's just a modern API in JavaScript to write asynchronous code. Everything in that body of the promise is what's done asynchronously, and we can determine our own what's a success condition, what's a failure condition. Like I stated in the beginning, it's a value for it's really a proxy for a future value. So you're going to get some value at the end of it. I also say it's the proxy for a completion of code. That's not really the textbook definition, but when a promise resolves or rejects, something else was completed, and you can handle it from there. And that guarantee I talked about earlier, a promise will always resolve or reject one time, just once. A promise will never run more than once, unless, of course, you knew it up a second time and do that. So two things I'll show you real fast, and then I'm not actually set up to do this super well right now, so let me switch over here to my decimator. I love the names of these projectors. It is so cool. Uh-oh, that didn't work. There we go. This is like a 1000K resolution here. So what I'll just highlight real fast, internet does not work in here. It's gotten worse throughout the day. The only thing I will highlight is that if you go, the GitHub solution I put out there, just lets you go through these examples I talked about here with code relative to the slides you see here. So the slides are available online too in the repo. You can grab those. The idea is that you can just hit a button here on the left, watch the code come out on the right. You can bust open the solution here, and all these examples are very hard to read. All these examples are just very well documented line by line examples that relate back to these slides. So hopefully you can pull this up in your browser all you want and play with it. The last thing I'll close with then is this slide, which, oh, that's the wrong button. That's also the wrong button. Oh. I'm actually I'm kind of a Mac guy, but I'm more of a, that's the slide that'll get you there. So if you want to grab that information, feel free. That goes to the GitHub repo. There's my information. Email me, find me on LinkedIn. And with that, thanks for coming out. Appreciate it.